Today I want to answer some questions from comments in the videos. I haven't had time during the week. I've had a look at the questions. There are some that I will answer now, some of them I will do in the next one. But one of the questions that came up was something that I was already trying to figure out how I can answer the question. And the question is, how fast is the river flowing? What is the speed of the flow? Now we know the volume of the flow, and to work that out I'm going to measure the distance that the river flows over a certain time. Now that's a bit complicated because the river's got some islands here and some different flows. The plan is to deploy some flow speed measuring devices, FSMDs. Now the FSMDs are these. 3 oranges and an apple. I'm going to throw them in the river, one near, one in the middle, one as far as I can throw it, and then another one I'll see if I can put it even further in, so that I'm spread out, so that if some of them get caught in the reeds downstream, I have a good chance of still getting some of them through. Now if you go on Google and you search for flow speed measuring methods, that's how they do it. They normally do it with a ping pong ball, but because the river is so wide, this is only a small stream, there are other streams beyond the island. What they normally advise is you drop in one, you measure the speed, and you do it again and again and again over a distance, and then average it out. There's no way I can recover a ball from the stream, so I'm going to use oranges and apples. I'm going to pop in the first one slightly upstream and then catch up with the rest. And then the apple, and then exactly at 30 seconds they passed the starting line. Man, they're going. You need to drive. I'll be spotting that, but while we're waiting for them, because I don't really know exactly how long it's going to take, we can answer some of those questions that I've mentioned. A question that pops up frequently is, is there any way to divert some of this water to the Eastern Cape where the drought is? Now the quick answer is yes. There's already a tunnel, there's already a scheme built that takes water from the Gariep Dam down to the Eastern Cape. The problem is that only a part of the Eastern Cape can benefit from this. Only the Sondags River Valley and Port Elizabeth can benefit from this. The Kouga Dam supplies Port Elizabeth, but it also supplies the Gamtoos Valley, which is beyond the mountain range, and water cannot be canaled to the Gamtoos Valley. Another question by David, a question specifically about the previous video where I showed the trees that are drowned, is how long did the trees take to drown? It's not a simple answer. First of all, in the 88 flood, the river rose to its peak, then it slowly dropped down, and then a week later it rose again, and then it stayed up for about a week before slowly starting to drop down. This will at the same time answer a question by another user, that is, how do you get the water out? You cannot get the water out. There's nowhere to pump the water. You have to wait for it to drop down, for the river level to drop down and the water to flow out by itself. Yeah. It's high. It's about 2,000 cubic meters per second at the moment. About 1,900 going up to 2,000 now. What's that on the other side? No, that's a bubble of foam. I dropped in a couple. They should be on this side of the river, but I dropped them in about 2 kilometers, just under 2 kilometers upstream.
Did you definitely manage to beat them down here?
Yeah, for sure. I would say in the next minute or so, there's an orange. Just above the reeds, there's an orange. So that's exactly What's this? 23.4 minutes, I think. I'm having trouble seeing the screen. So that was one orange. That's the first one I saw. I dropped in a bunch. I don't know if you see the reeds drifting. Just above it was an orange.
Okay.
So I went and did the calculations, and I'm not happy that I got a good measurement of the speed. So we're going to try it in 2 other different ways and see if we can get confirm it or get a better way to measure it. So let's see. I'm going to use the oranges. I'm going to put them in the stream. The water is too deep for me to walk up to where the actual bank is, and it's a straight section, about 500-600 meters. I'll measure it now. I'll monitor the oranges and time the oranges over that time frame, stop and start, and then I'll use the GPS to take another reading of what the speed is. Firstly, I'm going upstream a bit because I want to be at speed already when I reach the tree. There's an eddy just in front of us. I'm gonna have to cross. So I'm gonna have to cross this first little stream, get in that eddy, so that I can put the oranges beyond that eddy. Alright, so we're into this stream here. This is the center of this stream. The 2 oranges. Just want to be sure that I see it. I'm going to put one there. It's going to the right hand side. There's a lot of swirls. I'm going to put the other one a little bit more to the left. See if there's a difference between the 2 areas in the water and whether they just come together. Right, 3, 2, 1. Right next to the tree. There it is. We'll retrieve this one as soon as we pass the point. It's basically our own speed. We'll see what's happening to that one. That one has slowed down so much. Okay, so stop on the second one, over the first orange. Retrieve that one. So what did we learn? Well, for one thing, we learned that it makes a huge difference where in the river you are. So just putting in one orange and measuring it is not going to give you a good reading. We're going to have to I'm going to do it again. Right, I'm crossing again over to the main stream. Thing is, you see what happens here. That little stream on that side of this half of the river is much faster than where we are here. But if I put the orange in there, this stream picks up speed later on. So I'm going to deploy them wider this time. I'm going to put one in that fast stream there. And then I'm going to put one in that stream and we'll average it out. First one is now next to the tree. Second one will be in a moment's time. Look at the mountain, I would say there. The mountain with the mountains to the rear of it. It's about 50-50 that distance. We can check it, but so you can get a better idea of the speed there. Right here, it's as if we are standing still. It's in line with us. So I'm going to use ourselves. There it is, in line with us. So it's mark on the first one. And I want to get out of the stream. Okay, so that's Mark on the second one. Right, let's get out of the water and go do some calculations. So it's the next day. I did some number crunching and let's have a look at the numbers. So the first measurement I did over the long distance gave me a reading of 7.1 kilometers per hour. That was 2,260 meters. But there's a rapid in that section which will obviously push up the number a bit higher. The other four measurements I did with the boat tagging along to the oranges gave me 6.7, 6 kilometers, 6.5 and 5.5 kilometers per hour. The distance was 410 meters if you want to use those times and measurements to check my maths. Those 5 readings, while the last 4 readings was over a flat area and the first one is over some rapids, there are more flats than rapids on the orange, so I think using them in that ratio is fine for a rough estimate on the average flow. That gives me an average of 6.4 kilometers per hour, and that will give you 153 kilometers per day. Now if you take the measurement, the distances from Gariep Dam to Douglas and from Bloemhof to Douglas is 100 kilometers further than Gariep to Douglas, but Gariep to Douglas you have the Van der Kloof Dam that will delay that flow slightly by absorbing that over the the vast area of the Van der Kloof Dam. So I'm estimating that half a day's delay more or less, so we have roughly the same flow time from Bloemhof to Douglas as we have from Gariep to Douglas, and that flow time is 3 days roughly, and I'll explain why I say roughly in a moment. So from Bloemhof or Gariep to Upington is about 5.5 days, and to Grabies it's about 6.5 days. So it's about 1 day from Upington to Grabies. So from the dams to Kleinpella to me is 7.5 days. So while the speed measurements that I got is slightly lower than what I had in mind, the actual time is about a week is about what I had in mind. So I had the speeds a little bit wrong, but the time is about right. Now the caveat on all of these time estimations for flow from the dams is because it's 2000, it's a little bit above 2000 here. It's picked up overnight quite a bit, and it's going to pick up a lot now, the level. But the flow here might be 2000, but in Upington it's 3000. So it's not the same all over. And when the flow is increasing, you have a different speed of the flow down than when it's decreasing. When it's increasing, it's slightly slower because it has to fill the area as it raises up. And some of that speed of flow gets absorbed into the wider area that the river has to cover. While going down, it's going to go slightly faster going down because the surface area is decreasing. That's what I think. Correct me if I'm wrong, please, in the comments. So roughly, because today it's going to be different than it was yesterday. And as we don't have measurements all over giving us correct readings all over, that's going to change. So you'll have to, instead of just having a time of flow, you're going to have a slide scale, and it's going to be, I don't know if it's going to be an S curve on that sliding scale for the different flow rates. I don't know. What I'll do is I'll see if I can get a measurement when it's at its peak in about a week's time from now, 7 days from now, 6 days from now, and then I can plot at least 2, and then after all of this is done, the flood's gone down to normal flow, I can do, once again, I can do over a longer distance to get a more accurate reading. I can do a flow measurement to see what it's, so then I'll have 3 points that I can plot, and that'll give us a rough reading, and I can maybe draw up a table to see at the different levels. And the reason I'm going to that extent is not for the YouTube video and not because of the question in the comment only. It's because I want to know, because every time a flood comes, I want to know what those times are. So I'm doing it because I want the measurements and I want to have an idea of that time of flow. Then just before we finish this very long video, one comment that I missed. I read the comment and I've been unable to find it to reply to the comment in the video. It's about the coffee grinder situation. The coffee grinder, I know I need to get a better coffee grinder than the spinning blade one. I've been trying to find one. I saw some that were many thousands of rands. There's no way I'm going to do that, pay that for a coffee grinder. But a simple one with a burr grinder or something that will, I'll find it. I know I need to find a better one. I'll find it. Then I replied to some of the other comments in the comments, but one or two of them I might make a video about because they are more interesting than just the short reply that I can put up there, and more people ask the same kind of question. So it's worthwhile making a video, because if some people are asking the question, then there's probably more that are that they're not writing the question down, but actually it would be interesting enough to make a video. So that's it for this long video. I'll see you on the next one. Cheers. He likes to sit there while waiting. Or lie.